Let's talk about inclined plane. An inclined plane, when working with an inclined plane question, it is often best to divide force vectors into components that are parallel and perpendicular to the plane. So here we see that this is a vector of force, this is a force vector, or this is a weight vector, mg, and we have a normal force n here. Now, this weight force is decomposed into its components along the path and perpendicular to the path. But how do we know that if this is theta, this is theta? How do we know? Let me tell you in a bit of like geometry why it is the case. Let me take this A, and this point to be B, and this point to be A and B. And therefore, in this right triangle, OAB, I can say this is 90 minus theta. This is 90 minus theta, this angle B. Now, let's take this point C and take this point to be D, to be G, center, the center of gravity or centroid of the this box. In triangle GBC, this is 90 minus theta, and therefore this angle must be theta. Why? Because this is a 90 degree, which means the weight is perpendicular to the horizontal surface. And of course we use this perpendicularity here in triangle OAB because we said we want to decompose it into perpendicular to the surface and parallel to the surface. So this is perpendicular, this is perpendicular, so we prove that the angle that weight vector makes with perpendicular components is the same as the angle of inclined plane. It's clear that this is mg cosine of theta and mg sine of theta. So mg sine of theta will be usually parallel to the surface of inclined plane. Mg cosine of theta will be perpendicular to the surface of inclined plane, taking the theta as the angle of the inclined plane. Most often, gravity must be split into components for these calculations. So now we can start to study the motion of this box along this line, because we know what vectors are applying, and therefore if we usually take this to be x direction, parallel to the surface x, perpendicular to the surface y. Can we say that we have no motion in y direction? Of course, either it slides down or it stops. It has no direction in y direction. So sigma f of y equals 0, therefore normal force N is equal to mg cosine of theta. And whether we have a friction or not, it's something to be, it's something remains to be talked later. That if it slides down or not. Let's do one practice problem here. A 5 kilogram block slides down a frictionless inclined plane with 30 degree with horizon. So theta is given to be 30 degree. So we know that this is mg sine of theta. You know that it should be parallel to the plate, of course, and this is perpendicular to the surface, mg cosine of theta. So this is mg, sine of theta is half, so mg times half, and this is mg times cosine of theta, which is something like this, or let me write radical 3 over 2 mg. So the weight, The weight force is decomposed into these two forces. Another force acting on the object is, of course, N. As I said before in the previous slide, taking the x and y direction, we can say sigma f of y is equal to 0, and therefore normal force is equal to mg cosine of theta. What is the question asking? Find the normal force and acceleration of the block. Okay, so normal force is this. So 5 times g times radical 3 over 2. This is the normal force. The question hasn't said to take g as 10. Maybe it's 9.8 or 9.81, whatever. It's the final answer for normal force. And then acceleration of the block. There is no force of friction. It's a frictionless inclined plane. So there is no force other than this acting on it. So can we apply the second law of Newton? Yes. Sigma f of x is equal to m a of x. So we'll have acceleration in this direction. It accelerates to slide down. What is the force? So I can say mg sine of 30 is equal to ma of x. Mass cancels away. G sine of theta, or g over 2, will be the acceleration. So acceleration will be g over 2, or half of g. That's it. Let's do another question. In the figure, a box of mass 5 kilogram is left at rest. Okay, it is at rest. So we can say V0 is 0. Friction coefficients are static friction coefficient and kinematic coefficient friction are given, and the angle is 37. Okay, now here again the weight is decomposed into the horizontal and vertical components. So let's take the g to be 10. I forgot to say this question. So let's take the g to be 10. So the weight force will be 50. So 50, this is the angle theta, will be 37. So again we'll have a 3, 4, 5 triangle or Pythagorean triple. Therefore, let me remove this one and say that this is 40 Newton and this is 30 Newton, because this is 50 and decomposed into 30 and 40. Now, there is a friction force, there is a normal force. The normal force is 40 Newton. I explained it in the earlier slides why it is the case, because we have no motion in y direction. What about x direction? We have a 30 Newton force which is applying on the box, causing it to slide down. There is a friction force resisting this. Let's calculate the maximum friction force that can be applied. So the maximum friction force, maximum static friction force that can be applied is mu s times n. Mu s is 0.2, n is 40, so it will be 8 Newton. So 8 Newton cannot hold the 30 Newton, of course. Therefore, because 30 is greater than 8, we can say that the object or the box starts to slide down. So the maximum static friction cannot bear this force. Therefore, it slides down. It starts to slide down. Now that it starts to slide down, we can say the force of friction is kinetic friction. So we answered part A. That does it start to slide down? Yes, of course. What is the friction force? The friction force is F of K is mu K times N. Mu K is 0.1. N is 40. So the friction force is 4 Newton. And in part C, the acceleration is asked, so we can say sigma F of X, or resultant X in X direction, resultant force in X direction is equal to ma of X. I'm writing a of X that it says the acceleration in X direction, but I can neglect X. I can simply write A. What is the resultant force? 30 minus 4, because 30 is causing it to move, 4 is resisting force. And mass is 5, and acceleration will be found. Acceleration is 26 over 5, and if we multiply both numerator and denominator by 2, it will 52 over 10, or 5.2. The unit is, of course, meter per square second. Okay, this is the last example in this session. A box is shot at an initial speed of 10 meters per second so that it slides up an inclined plane. So it is here initially. The box is here initially. We apply. We just apply force and leave it, so that we can say that the initial velocity, it is shot, so the initial velocity is 10 meters per second, and then the vertical components of the force cancel out each other, and there is a force of mg sine of theta causing this box to slide down, to slow down. Of course, nothing has said about the friction, so take no friction. Let's say it's a frictionless plane. Okay, so this force is slowing down the object. So we want to know how long does it move before it stops. So first, let's find the force applying to the object. The force applying to the object is mg sine of theta, and can we say the acceleration is g sine of theta? Yes. What is the g sine of theta? It is 5. G is 10, sine of 30 is half, so the acceleration is 5. Can we say acceleration is negative 5, given that we have taken the v0 to be positive 10? Yes. Now, v is equal to v0 plus at, and at the final position when it comes to stop, v is 0, v0 is 10, and negative 5t, so we'll find that after 2 seconds it comes to stop. Why did we take the acceleration to be negative 5? Because the initial velocity is taken to be positive in this direction, and we know that acceleration is applying in this direction. Therefore, we should take a to be negative 5. Between which 2 points this equation is written? Between the initial position and the final position, where the final velocity is 0. So final velocity is 0, initial velocity is applied, so we can say the time. How long does it take before it comes to stop? 2 seconds. What is the distance it goes before stopping? Now we can apply different formula, but if I apply the time independent formula, it will be like this. Again, between initial point and final position, 2a delta x, and therefore delta x will be 10. So 10 meter, it goes 10 meter up, or we can say this is the height will be 5 meter. But what is the distance it goes? The distance of 10 meter. It goes 10 meter before it stops. Okay, so I use this formula of time independence to find the distance covered. Of course, I could solve this part B with several other formulas. Another way to solve it, for example, it can be solved like this. This is another way. V0 is 10, V final is 0. So can I find the average velocity? Yes, the average velocity will be 5 meter per second. Now we have a general formula in physics that says delta x over t is average velocity. So delta x will be average velocity 5 times time will be 10 meter. Again, the same result will be found. I mean, whatever formula you apply, you will get the same final answer.